Good morning, friends. Today we will going to see how measurement of the network. So, how you are going to measure the network. As we say in the case of social media, the graph is a huge graph, and now whenever we want to actually go for the shortest path, or we are interested in how close a particular user, or how it is more interactive, or how many users are similar to each other. So in that case we do need the measurement of the graph. So we said initially the first thing that we require, if we want to find out who is the central figure uh, or the influence individuals in the network, right? So that we can find it out with the help of the centrality. Then the next thing that we can find out what interaction patterns are common between the friends. So that we can find out with the help of reciprocity or transitivity or balance or status. Similarly, we do, if we want to find out how many users are there, they are think similarly, that is like-minded users are there. So the similarity between the users we can find out with the help of similarity. So to identify the centrality, the level of interaction as well as the similarity among the other users, we do require the need of measurement of the network. So first thing that we will going to see in the today's lecture is how to define the centrality of the network within the network. So centrality in the terms of who are connected to whom. So that is the center figure that we are talking about. Some maximum connections to that users that we will going to calculate as a centrality. So as we had seen in the previous lecture, that is the basis of graph, as well as we had seen in the second year also, that is nothing but the degree of the graph. So what we will say, the degree of the vertex that we will going to say. So the degree of the ith vertex is it will be going to be represented by Cg, and that will be the dr. So dr is going to indicate the number of friends in the case of social network that we are talking about, and the number of length will be that will be in generalized, we can say it will be length minus 1. So now in this graph it will say it will be nothing but it will be the combination of in degree and the out degree. So how many incoming edges are there to that particular vertex, and how many out, that will be called as the in degree, and how many outgoing edges are there from that particular vertex will be called as the out degree. So as you are going to see, as this is the undirected graph, so we will say in degree and the out degree will be the same. So we will say the number of incoming edges to this particular node will be 8. So the degree of the vertex V is 1, and the number of edges connected to the other vertices are just 1. So the degree of other vertices other than the vertex number 1 will be 1 over. So now, if this is called as this is applicable for the undirected graph. Now, if you want to see what will be happen in the undirected graph, so we do have to focus on the in degree and out degree. So we will say now mostly the in degree is used as a prestige. So it will be the prestige that the number of people want to be my friend. So CD of VI will be nothing but it will be the in degree of that particular vertex, ith vertex, and that will be the prestige of that particular vertex. Now CD, that is the out degree of VI. So out degree of VI will be denoted by VI of out, and that will be indicated by Gregorian-Miss. Means how friendly a particular user is. I'm approaching to a many users, and I want that many users should be my friend. So what we will say, that will be called as a this, and that will be indicated by the DI of out. Now, and the degree of a particular node will be nothing but it will be in degree plus out degree. That is the number of outgoing links of a particular node here. So now, as in the graph, we can't focus on as this is the dense graph of the social network. So we can't focus on and we can't find out the in degree and out degree of a particular node, and then after that, by doing the comparisons, then we will be going to find out the centrality part. So over here, what the concept is come, that is the normalized degree centrality. So we can do the normalization by three ways. One is the normalized by the maximum possible degree, and that is nothing but the formula that is given by. So I want to find out the normalized degree of the vertex Vi will be nothing but the degree of that vertex divided by n minus 1. So over here the n minus 1 is the number of vertices in the n is the number of vertices in the graph, so that will be number of vertices minus 1. So the normalized degree of centrality can be find out by the maximum degree also. So that will be find it out will be Di, that is nothing but the degree of that particular node, and whatever the other nodes, that is dj of other nodes, that will be denoted by dj other than the ith vertex. So we will going to find out which vertex will have the maximum degree, and that will be divided by that. The next one we will going to say we will going to find out the normalized degree centrality by the normalized by degree sum. So we want to find out the centrality of the vertex Di, that is nothing but the degree of vertex Di, and we will just going to sum all the degrees of the other vertices other than Di, and that will be divided by that. So as we had seen in the theorem 1 in the previous lecture, we will say that the sum of all degrees will be nothing but it will be twice the number of edges that we do have. So so we will say whatever the number of edges that we will going to get, and that will be multiplied by 2, it will be twice. So it will be nothing but we will say the number of edges that we have in n. So finally the normalized normalization by the degree sum will be nothing but Di divided by 2m, where n is the number of edges in the graph. Now we will just take one example over here. So this is the directed graph. So in the case of directed graph, what we are going to do, we are just going to focus on the out degree instead of focusing on the in degree. So now in this case, we do have, in this particular graph, we do have the 7 number of nodes, that is from A, B, C, and it will be up to G. Now, as we say, the in degree of vertex A is 1, that there is only one incoming arrow towards the vertex A, and the out degree of the vertex A is 3. So as we are saying, there are 1, 2, and 3. There are the 3 outgoing edges over here. So according to that, what we have to do, we do have to do the calculations of we going to find out the in degree and the out degree of a particular node. Now after that, once we find out the in degree and out degree of a particular node, after that we will going to find out the centrality of that particular node. So now normalized centrality. So the normalized by, as we had seen in the previous slide. So normalization will be going to do by just by taking the maximum degree of the other node. That way we will going to do, or either it will be the summation of all the degrees, that is the twice, and the third more is there, that is we will just going to take normalized by maximum possible degree. We will just going to do that thing. Just a minute, let me use my marker pen. Now what we are going to do, now over here for this particular graph, I do have to focus on only the centrality part. So for finding the centrality, the formula that we had is normalized by maximum possible degrees. It is nothing but the normalization that we are going to use. We want to find out the centrality of the vertex Vi, that is nothing but Di divided by the number of vertices. So for the, as it is the directed graph, we are just going to focus on only out degree. So it will be nothing but, so we will the centrality of the vertex A will be nothing but the degree of the, and over here it is the out degree. So out degree of the vertex A, that is nothing but the 3 divided by the number of vertices minus 1. So the number of vertices in this graph is 7. so it will be divided by 6. So ultimately it will become 1 by 2 over here. Similarly, we will just going to calculate the centrality of the vertex B. It is nothing but, now as it is the directed graph, we are just going to focus on the out degree divided by the number of vertices minus 1. So this will be nothing but 6. So it will be 1 by 3 over here. So in this way, we will just going to find out the centrality of a particular graph. Similarly, if it is the undirected graph, now this is the graph over here, what we said, this is the undirected graph. So this is going to tell you whatever the number of edges that are connected to a particular vertex. Now over here, to the vertex A, the number of edges are connected are nothing but it is the 4. So degree of this particular node is 4. And as we are going to lightly normalize max degree centrality, so as according to the formula, so CD of VI is nothing but VI divided by n minus 1. So for the first thing, it will be 4 by number of edges are 7, so it will be 6, and that is nothing but it is 2 by 2, right? So according to this, we are going to calculate the centrality of a particular graph. So Ayush, any doubts do you have up to this? There is a glitch at my end of the recording of this lecture. My end.